A question again coming from 3D related to planes, parallel planes, an easier one again. You can see this is a plane and this is another plane and this is the third plane, and the distance between the planes is given, that is 1 by 3 and 2 by 3. So, if this plane is having distances from these two planes as 1 by 3 and 2 by 3, what are the values of lambda and mu? That is the maximum value of lambda plus mu is asked. That means there are more than one possible values here. Now, you can see the direction ratios of normal of this plane is 2 minus 1 and 2, and again 4 minus 2 and 2. That means they are in the same ratio, and this is again 2 minus 1 and 2. Now, this plane is okay, that is 2x. I will be writing in the same manner. But this plane, to bring the coefficient same, will be dividing with 2. So, this plane is this, and again the third plane which is given to us, I am writing here. Now, it is given that the distance between these two planes is 1 by 3. So, definitely we know the distance between the plane, it is d1 minus d2, that is 3 minus lambda by 2 upon under root a square b square c square. So, it is under root 9. Now, this is equal to 1 by 3. So, from here opening this mod, this will give you two values of lambda, but the maximum value will be 8. Right. Again, the distance between the first and the third plane is given to us, and that is equal to 2 by 3. So, applying the same formula here between these two planes, we have 3 minus mu upon under root 4 plus 1 plus 4, that is 9, is equal to 2 by 3. Now, from here again you will get the maximum value of mu as 5. So, there will be again two values. Now, applying the mod is very important, otherwise you will get only one value. So, the maximum value of lambda plus mu which is asked here is equal to 13. So, the first option is the correct one. Let us move to the next problem. The next problem is on limits, again an easier one. The limit of x square minus ax plus b upon x minus 1 is equal to 5. The limit is given to us. We want to calculate the value of a plus b. Now, let us check the form first, because before evaluating you first see what is the form. If you place x equal to 1, you can see the denominator is becoming 0, and at x equal to 1 the numerator is 1 minus a plus b. Now, if this is any non-zero finite number, you will see that in the denominator it is 0, and if this is non-zero finite number, the limit will not exist. So, for the limit to exist, this has to be 0, because the limit is given to us is 5. So, this has to be 0. This is the first equation we are having. Now, with this condition, that is 1 minus a plus b is equal to 0, the numerator is becoming 0. So, we can go for the L'Hospital rule. Differentiating the numerator, we have 2x minus a, and the denominator is definitely 1. Limit x is tending to 1. Now, applying the limit, that is x equal to 1. In the numerator, we are having 2 minus a, and the denominator is 1. So, this is the limit, that is 2 minus a, which is given to us is 5. So, from here we can get the value of a, which is equal to minus 3, and placing here we will get the value of b equal to minus 4. So, the value of a plus b is definitely equal to minus 7, an easier one, and we have the correct option as fourth option. Let us move to the next problem. This problem is related to finding out the roots of this equation, and there is a modulus sign which is involved here. You can see the value which is inside this modulus, that is 2x minus 1, will become 0 at x equal to 0. So, we will be taking this problem in two cases. First, for x greater than or equal to 0, this will be positive. So we are opening this modulus with a positive sign. So opening with the positive sign, we have here this equation in exponential. Now again, to simplify things, we are putting 2x equal to t. So this will be a quadratic in t. This is 4 plus t equal to t into t minus 2. So the quadratic is t square minus 3t minus 4 is equal to 0. From here we will get two values of t. Now one value is 4 and another value of t is minus 1. Now what is t? T is 2 raised to the power x. So if 2 raised to the power x is equal to 4, x from here will be equal to 2, and definitely 2 raised to the power x is not a negative value. So you won't be getting anything from here. So the only value from the first case is x equal to 2, and that is greater than 0. That has to be noted. So this is the solution. Now let us see another solution if we get any. Now the second case is when x is less than 0. When x is less than 0, you will notice that the quantity inside the modulus sign will be negative. This quantity will be negative. So this modulus will be opening with the negative sign. So what is the equation we are having now? It is 5 minus 2 raised to the power x minus 1, and on the right hand side we are having 2 raised to the power x into 2 raised to the power x minus 2. Now we need to solve this equation. So let us see what we will get. Again, putting 2 raised to the power x equal to t, we have 6 minus t is equal to t square minus 2t. So this is again a quadratic. T square minus t minus 6 is equal to 0. So here again we have two values of t. One is definitely, one factor is t minus 3, other is t plus 2. So this is equal to 0. So t from here is 3 and t is equal to minus 2. So let us see what are the values of x. So 2 raised to the power x is equal to 3 and 2 raised to the power x is equal to minus 2. As we know, this is not possible, and this is possible only for positive values of x. But this is the case when x was less than 0. So again we will be neglecting this. So the only value which we have got from here is from the first case, and that value is equal to x equal to 2. So let us see which one is the correct option. The correct option is the second one. So here we are. Let's move to the next problem.